Welcome to the DIY Honda Garage channel. The DTC P0716 pertains to the input turbine speed sensor A circuit range or performance issue in the Honda HR-V, specifically from the 2016 to 2022 model years. The input turbine speed sensor is crucial for monitoring the speed of the rotating turbine within the continuously variable transmission CVT. This information is vital to ensure that the transmission operates smoothly and efficiently, optimizing the vehicle's performance and fuel economy. Consequently, a malfunction or disturbance in this sensor circuit may lead to erratic shifting patterns and performance failures. As such, this DTC indicates there is an electrical circuit problem rather than a mechanical failure in the transmission component. Proper diagnostics and corrective measures can safeguard the functionality of the transmission system in your vehicle. The input turbine speed sensor A measures the rotational speed of the turbine inside the CVT, crucial for ensuring proper fluid flow and gear ratios. This sensor is typically situated within the transmission assembly, making it an integral part of the transmission system. By providing feedback to the powertrain control module, PCM, this sensor allows the vehicle to adapt and optimize performance under varying driving conditions. An issue with this circuit can lead to poor shifting, reduced fuel efficiency, and overall degraded vehicle performance. It's imperative to understand that any detected DTC related to the input turbine speed sensor indicates problems in the sensor circuitry rather than the mechanical parts of the transmission. Consequently, pinpointing the exact electrical fault is essential for effective vehicle servicing. The primary causes of the DTC P0716 are linked to electrical circuit issues within the transmission's input-turbine speed sensor. Firstly, problems can stem from poor connections, where the wiring is not making sufficient contact, leading to inaccurate readings or complete signal loss. Secondly, loose terminals may disrupt the electrical path, causing intermittent or erratic performance of the sensor. It is emphasized that this DTC cannot arise from mechanical issues within the transmission. The problem is strictly electrical. In most cases, identifying these issues requires careful inspection and testing of the associated wiring and connectors. If the electrical circuit is intact and functional, yet the DTC persists, further investigation into the sensor itself may be warranted. When a vehicle triggers DTC P0716, drivers may notice several symptoms, primarily related to the transmission shifting capabilities. One evident symptom is erratic shifting, where the transmission may shift harshly or unpredictably under normal driving conditions. These irregularities can lead to a decrease in overall driving comfort and vehicle performance. Additionally, core transmission performance may manifest as sluggish acceleration or hesitations during gear changes. Another common indicator is illumination of the check engine light on the dashboard. This alert serves as a warning that something is amiss within the vehicle, necessitating further diagnostics. Nevertheless, it is essential to approach these symptoms with caution, as they can sometimes indicate broader transmission problems beyond just the sensor issue. To initiate the troubleshooting for DTC P0716, it is essential to verify the problem first. Begin by turning the vehicle to the on mode without starting the engine. Once this is done, connect the Honda Diagnostic System, HDS, and clear the existing DTCs. This process helps reset the system and allows for accurate diagnostics during the following checks. After clearing the codes, turn the vehicle off and securely raise it on a lift, ensuring all four wheels can rotate freely without obstruction. This step is crucial to simulate normal driving conditions and assess sensor performance under load. Always ensure the vehicle is safely supported before proceeding to the next steps in the troubleshooting process to avoid any risk of accidents. Following the initial verification, The next step involves a test drive of the vehicle. While keeping the vehicle in drive, D mode, accelerate to speeds exceeding 19 miles per hour, 30 kilometers per hour, and maintain this speed for at least 30 seconds. This testing is crucial as it allows the vehicle's systems to operate under conditions where the turbine speed sensor should function optimally. After this period, stop the vehicle and utilize the HDS once again to check for any confirmed or pending DTCs. A successful test drive will either confirm the presence of DTC P0716 or indicate that the system is currently functioning correctly. If DTC P0716 has reappeared, this suggests that there is a fault present that requires further investigation into the sensor or circuit. Conversely, if the DTC does not appear, an intermittent failure might be at play, warranting checks on the connectors and terminals. In this step, the focus shifts to the actual performance of the torque converter turbine speed sensor. Rotate the front wheels while the vehicle is in drive, observing the RPMs of both the torque converter turbine speed and input shaft drive pulley using the HDS data list. This comparison is crucial as the two speeds should correspond closely under normal operating conditions. By analyzing the data, you can identify whether there is a discrepancy between the expected and actual performance of the sensor. If the two RPM readings are nearly identical, it suggests that the sensor itself is functioning correctly. In such a case, it may be necessary to update the Powertrain Control Module (PCM) software to the latest version or replace the PCM entirely if it is deemed faulty. Thus, accurate data comparison is essential during this diagnostic step. If the RPM readings of the torque converter turbine speed and input shaft are not similar, the next logical step is to replace the torque converter turbine speed sensor. A significant variance in these readings indicates that the sensor is malfunctioning and not providing accurate information to the PCM, impacting transmission performance. After replacing the faulty sensor, it's crucial to perform another diagnostic check to see if DTC P0716 persists. If the DTC clears after the repair, the issue has been resolved, and the vehicle should return to normal operation. However, if the problem continues, there might be further electrical circuit issues that need investigation. This step emphasizes proactive replacement and subsequent verification, ensuring the vehicle runs smoothly post-repair. Once repairs have been made, it is vital to conduct a final verification process to ensure that the issue has been completely resolved. Begin by taking the vehicle for another test drive, replicating the conditions that previously triggered DTC P0716. During this drive, monitor the transmission's performance, checking for smooth shifting and overall functionality. After completing the test drive, utilize the HDS to check for the presence of any DTCs once more. If DTC P0716 does not reappear, it indicates that the repairs were indeed successful and the vehicle is operating as intended. Additionally, ensuring that the transmission engages correctly during driving conditions solidifies that the repair was on point. The verification stage is crucial in confirming the effectiveness of the troubleshooting and repair process. To prevent encountering DTC P0716 in the future, incorporating regular preventive maintenance is advisable. Begin by routinely inspecting the wiring and connectors associated with the input turbine speed sensor, ensuring that they are intact and free from corrosion. Over time, electrical components can wear out, leading to connectivity issues that can trigger DTCs. Additionally, remaining vigilant about software updates for the PCM is essential, as manufacturers frequently release updates to enhance performance and rectify known issues. Performing these updates ensures that the vehicle benefits from the latest advancements in technology. Lastly, Routinely checking the connections for tightness and integrity will allow easy detection of intermittent issues before they escalate into more severe problems. A proactive maintenance mindset can significantly enhance vehicle longevity and performance. In summary, DTC P0716 represents an electrical issue pertaining to the input Turbine Speed Sensor A circuit in Honda HR-V models from 2016 to 2022. Understanding that this code is caused by electrical faults rather than mechanical problems is crucial for effective troubleshooting. Key to efficient repair and resolution is conducting thorough diagnostics and following each troubleshooting step methodically. By ensuring rigorous checks of sensor conditions, performance evaluation, and connector integrity, a successful resolution of DTC P0716 can be achieved. Further, adopting preventive maintenance practices will reduce the likelihood of future occurrences of this DTC, ensuring smoother vehicle performance and enhancing the owner's driving experience. Properly addressing this DTC ultimately leads to reliable transmission operation and contributes to the overall health of the vehicle. Please like and subscribe to the channel. See you next time.